Hello, welcome to the Vietnam guide that you're going to make for the map. You are going to need this to get as many points as possible. This is going to help you through every mission in this first destination. So this is kind of a quick overview of everything you need to know about this unit, all about exponents. If you have trouble with any part of this, that's fine. We have extra support videos and you can do some more practice. You can ask us for help, but this is the overall view. So for those of you who don't want to watch a video on every single one of these rules, you can just get all of this down and use this all the way through. When you get to the big boss battle, though, you won't get to use this anymore. So make sure you know the rules by the time you get to the big boss battle. Are you ready to start? Let's go. The first one is just review of last year. Adding and subtracting monomials means if they are like terms, if they have the same base and the same exponent, you just combine them. So for example, number 1 says 9x squared minus 10x squared y. 9x squared y minus 10x squared y. If you notice, they're like terms. They have x squared y, x squared y. So all I do is subtract. So 9 minus 10 is negative 1. I don't have to write the negative 1 because I have negative x squared y. If you wrote negative 1 in front, that's totally fine. It's just, why do more work than you have to? So that's negative x squared y. Okay, don't forget, it's always hard for me to write on my computer like this, so listen to me as I do it so you know what to write down. For this next one, number 2, subtract 6 w's from 8 w's, again, like terms. And I'm taking the 6 away from the 8. So really I start with the 8 w's, and I subtract 6 w's, and that gives me 2 w's. It's just a little review. We learned it last year. You're going to do it a lot this year, so let's make sure you know. This next one is the product rule. Product means multiply. I know it's been a long summer, but product means multiply. If I'm multiplying two bases that are the same, all that I have to do is add the exponents. And I'll prove it to you in a second, but this is the rule you need to write down so you don't forget. So basically, if the bases are exactly the same, all that I have to do is add the exponents. I'm going to prove it to you. In number 1, I have h squared, and I have h to the 6th. That means I have h times h, right? That's what h squared means. Write that down. If I have 2 h's there, and that means I'll have 6, I'll have the product of 6 h's here. I'm going to write that as quick as I can. You need to write it on yours as well so you can see it. Okay, I have 2, 3, 4, 5, 6. Check to make sure I have them enough. 1, 2, 3, 4, 5, 6, 7, 8. Oh, how many do I have? I have 8 h's. So instead of writing this out every single time, wouldn't it be just easier to add the 2? So h to the 2nd plus the 6th gives me h to the 8. Make sure you have that down. The next one's the same thing. It just looks a little different because it's a little bit more involved. If I have negative 2 here, that's the coefficient if you recall, and this is 7, I always multiply the coefficients first. That's easy. Negative 2 times 7, I hope you remember it's negative 14. Okay, good. Now let's take care of the bases and the exponents. If you notice, I have a base of a squared, and I have a base with a to the 3rd. Well, these two bases are the same, the a's. So all I have to do is add the 2 and the 3. So now I have a to the, what's 2 plus 3? 5th. That's right, a to the 5th. Now this b and this b are the same. They have the same base. I don't see an exponent. If there's no exponent, we know it has a 1 for an exponent because that's just, there's one b. So that means I have b to the 1st plus b to the 1st, or times b to the 1st, sorry, and that's b squared. So my answer here is negative 14, a to the 5th, b squared. So remember the product rule. If the bases are the same, you just add the exponents when you're multiplying them. Now the power rule is a little different. This is a power to a power. So you're taking that power that many times. So this time, instead of adding them, because remember, I'm not multiplying, it's a power to a power. That means I'm going to do 8x to the a times b. All right, we can handle this. So if we use this rule over here, that means I have x to the second times 3. So it's x to the second times 3, which gives me x to the 6th. Good. Next one's the same thing. I just need to simplify this part first before I can multiply times m to the 3rd. Ooh, this gets a little tricky. If I have a negative 2 here, and that's being taken to the second power, it's negative 2 times 2, which, or not, oh my gosh, it's summertime. Negative 2 to the second power means negative 2 times negative 2, right? Okay, so I'm going to write that over here so you don't forget. I'm just showing you this over here as an example. Negative 2 times negative 2 is 4. Okay, for a start. Now I have m to the 5th taken to the second power. So our rule over here says if I have a power to a power, I just multiply the exponents. So I'm going to write the m, and I have to the 5th power times to the second power. So 5 times 2 is 10. But I'm not finished because I never did anything with this m to the 3rd. So I'm going to rewrite that. Okay, now the 4 doesn't really do anything. It stays the same because there's no other number to multiply it by except for 1. So I have 4. Now these bases are the same. So if the bases are the same, let's go back to the original problem we had up here. That's a product rule, right? If the bases are the same and now I'm multiplying them, what do I do with those exponents? Well, up here we learned that the product rule says we do what? We add them. So this should be, and I'm going to have to rewrite it over here so you can see it, it's 4m to the 13th power. Okay? Can you see it's a 3? Okay. That means we just used a couple of rules inside of that. All right, let's see if we can scroll down a little bit here. Quotient rule. Quotient. Quotient means divide. So if I'm dividing here, this means, now imagine this, when we were multiplying, we added the exponents. If I'm dividing them, guess what I do with the exponents? What's the opposite? I subtract. So it's x to the a minus b. Okay? Now, I hope you can see through my little video here. Let me see if I can, oh, there we go. Look at it. I can move me. Over here. Let's do this first. Let's take part of the x's. If I have x to the 5th over x, doesn't that really mean that I have x to the 5th minus 1? So really I have x to the 4th here. And I'm writing that on top because now that I've subtracted, that x on the bottom is gone. Now I have 27 on top and I have 42 on the bottom. This is just a fraction I need to simplify. I'm thinking that I know 3 and 9 go into 27, so why don't I divide 27 by 3? That gives me a 9. And I know 42 3 will divide 42 also. 3 will divide 42, let's see, it goes into 4 once, and then it would be 12, so it would be 14. So my answer here is 9x to the 4th over 14. Okay. Number 2, if you notice, look at this. I have a rule within a rule. We just learned about this. This is the power rule. Remember what we said, if it's power to a power, you add the exponents. So I have y to the 4th power over y to the 4th power. Ooh, I like it. Can you see that it's a 4? Okay, I got y to the 4th power on top because it's 2 times 2. Now if you notice, it says y to the 4th over y to the 4th. Well, if I have the same thing on the top and the bottom, quotient rule says I subtract these two exponents. What's 4 minus 4? Well, it would be 0. But we haven't gotten to that rule yet. So what I want you to really notice is what kind of fraction do we have if the top and the bottom are the same? It's a fancy form of 1. So that answer right there is 1. Okay, I'm going to try to scroll down here. See if I can. I cannot. Give me a second. I'm going to clear the screen, so make sure you have this. Okay, I'm going to do my best here. The negative exponent rule. This is what I need you to know. Negative exponent rule gets a little bit icky, gets confusing. A negative exponent means, and we can prove it to you if you have a hard time with this, it means you're going to rewrite this as a fraction. So Mrs. Pearson will call this dropping the F-bomb. You write this underneath 1. If it's a negative, we want to get rid of the negative exponent, and we just rewrite it as a positive, but underneath the number 1. So for example, in number 1, we have 5x to the negative second power. Now I'm only dropping this part because that's the base and the exponent. Negative 5 is not the base. So it's negative 5 over x to the positive 2, because once you write it as a fraction, it gets rid of the negative. Now this one's nice. I have 4 on top, 8 on the bottom. Well, 4 over 8 is a fancy way of saying 1/2. And I have k to the second on top, and I have k to the fifth on the bottom. Now, in the quotient rule, we learned that if the bases are the same, you subtract the exponents. So this really means k to the second minus 5. Well, what's 2 minus 5 is going to be a negative 3. So that means I have a k on top to the negative third power. Well, I don't want a negative third power. So that means I have to write the k on the bottom. So this means I have 1 over 2k to the positive 3. Remember, as soon as I write it as a fraction, it's a positive. Okay, good luck with this. Don't lose it, and make sure you submit to show that you did it.